Hello, this is Scholar Strife doing some math today. In Algebra 2, we'll be graphing simple rational functions, and they're not as simple as their name says. Rational functions, they have the form, change my pen, have the form f of x equals p of x over q of x, where p and q are polynomials, and q cannot equal 0, of course. And a hyperbola is a graph of a simple rational function that has two symmetrical parts called branches. Alright, now let's look at the parent function. The parent function of all these is y equals 1 over x. This is our inverse variation. We have a vertical asymptote at x equals 0, and then a horizontal asymptote at y equals 0. Our domain is all real numbers except 0. Because if you put 0 for any one of those, you'll have 0 in the denominator. And, well, yeah. We do not divide by 0. If I plug -2 into this equation, I get -1/2. Put -1, I get -1. Put in 1, you get 1, and then you get positive 1/2, and it looks like this. So we have asymptote on the vertical side as well. And if I plug in 1, I get 1, and then 1/2. -1, -1/2. And this is what your graph looks like. Alright. Graphing simple rational functions. So the equation looks like this. Y equals a over x minus h plus k, where we have a vertical asymptote at x equals h and a horizontal asymptote at y equals k. A still does your simple stretch, shrink, flip, or reflection, as they call it. And then h is your horizontal shift, left or right, and vertical shift for k, up or down. So, for example, we have y equals k for our horizontal asymptote, and then we have a vertical asymptote at x equals h, and then your graph would look something like this. They approach these asymptotes but never touch. Alright, how to graph these? First, draw your vertical asymptote and your horizontal asymptote, and then use a table to plot points on both sides of your asymptote. And then draw in the curve. So let's do an example here. So y equals -4 over x plus 2 minus 1. So let's figure out our variables here. A is the number on top, -4. H, okay, remember we always want to use the opposite, so if it's +2, it's -2. Because our equation is x minus h. So x plus 2 means that 2 is actually negative. So k always tells the truth, -1. Vertical asymptote x equals -2, horizontal asymptote y equals -1. Okay, because this is x equals h, y equals k. Domain, everything but -2. And range is everything but our k value, -1. So let's go ahead and draw those in there. So asymptote at y equals -1. Remember, that's a horizontal line at y equals -1. A vertical line at x equals -2. You want to make these dash because that's not your graph. Okay, and now we want to use 2 points to the right of the vertical asymptote and 2 points to the left of the vertical asymptote. So the vertical asymptote is at x equals -2, so I'm going to use -4 and -3, and then -2, and then let's see, -1 and 0 for the right of it. So if I plug in -4 to the equation, I will get 1. If I plug -3 into the equation, I'll get 3. If I plug in -1, I'll get -5. And then -3 if I plug in 0. So let's see what this looks like. -4, comma 1, -3, comma 3. Okay, so what's going on is we have, there's our one curved branch here. And let's do the other side. -1, comma -5. And 0, -3. 1, 2, 3. So we got this going on. And there, that's it. 2 little curved branches. So hopefully this is not too bad. Let's do some more. Alright, now what if they have this type of form? Y equals ax plus b over cx plus d. Alright. So you need to remember that there's a vertical asymptote at x equals -d over c. A horizontal asymptote at y equals a over c. So let's do this. So first thing we need to do is find a vertical asymptote. Okay, vertical asymptote is -d over c. So make sure we label everything. This is a, b, c, d. Okay. So equals -d, which is -3, over c, which is 1. So negative times negative is a positive, so I have 3. Okay, so this vertical asymptote, x equals 3. A horizontal asymptote, okay, remember, is a over c, which is 2 over 1. So y equals 2. So our domain, everything but our vertical asymptote, so except 3. And our range, everything but our y, equals 2. Alright, so let's draw in our vertical asymptotes. X equals 3, 1, 2, 3. And a horizontal, y equals 2. Alright, Now we're going to just choose points using our vertical asymptote. Our vertical asymptote's at 3. So to the left is 1 and 2. And to the right is 4 and 5. So if I plug in 1, I'll get 1 and 1/2, or 1.5. 2, I'll get correction. I was looking at my wrong notes here. Alright, so I want to plug in 1, 2, 4, and 5. If I plug in 1, I'll get negative 1.5. If I plug in 2, I'll get negative 5. If I plug in 4, I get 4. And if I plug in 5, I get 5.5. So let's see what this looks like. So 1, negative 1.5, 2, negative 5. Okay, so it looks like it's doing something like this. And you can always test more points to make sure you're going in the right direction. 4, 4, and 5, 5.5. Let me check one of these. So if I plug 4 in the equation, 2 times 4 is 8, plus 1 is 9. I was confused because that does not fit the shape, but now it does. So 4 is 9, 5 is 5.5, so it may do something like this. Alright, let's move on. Part B. Alright, A, B, C, D. Vertical asymptote is x equals negative D, which is negative 2, over C, which is 4. So this will become positive 1/2. Horizontal asymptote, that is y equals A over C, which is 2 over 4, which is also 1/2. So domain and range is both 1/2 except, or all real numbers except 1/2. So 1/2 here, and 1/2 up here. So I could use 1 and 2, and technically use 0 and negative 1 for the left side. So if I plug in 1, I get 1.5. If I plug in 2, I'll get 5 over 8 minus 2 is 6. And then if I plug in 0, I'll get negative 1/2. And if I plug in negative 1, I'll get 1/6. Alright, so let's see what this looks like. 1, 1.5, 2, 5, 6. So this is really on the edge there. And then 0, negative 1/2. And negative 1, comma 1/6. So it's already super close to the line already. So it's going to do something like that. A 3D printer builds up layers of material to make three-dimensional models. Each deposited layer bond to the layer below it. A company decides to make small display models of engine components using a 3D printer. The printer costs $24,000. The material for each model costs $300. Write an equation That gives the average cost per model as a function of number of models printed. So average costs so if we want the average cost, we're going to take our 24,000 plus 300 per model and divide it by how many models we made. So if we made only one model, that'd be a very expensive, should have just rented a printer. It would be a really expensive model. But if you made, I don't know, 1,000 models, the cost per model isn't that much. Graph the function using a graphing calculator. So you'd punch this into your graphing calculator, and your graph, if they give you, would look something like this. And they wouldn't show you the left side because we're working with positive numbers. And then you would notice that at around 60, you'll get $700 per model. So this is about 60 models. Now what happens to the average cost as more models are printed? As more models are printed, the average cost goes down. Okay. Because once again, like I said, if you made one model, that would be $24,300 model. If you make 10 models, that would be 24,000 plus the 3,000 for the models divided by 10. And you'll see the average gets a lot smaller the more models you make. Hopefully this helped you out. Have a good day.